Okay, we are going to work more with area today. We have two new formulas. We're actually working with three shapes, the trapezoid, the rhombus, and the kite. But the rhombus and the kite have the same formula, okay? And the formulas are really different, but they're kind of similar, so make sure that you get them straight in your head so that you don't get them confused. All right, the first one deals with the trapezoid, and it is half the height times the sum of the bases. Now let's just refresh our memory on what a trapezoid is. It's quadrilateral. It's got one pair of parallel sides. Those are our bases, base 1 and base 2. The height is perpendicular to both of those bases, okay? That's basically what your trapezoid is. Now, sometimes you might encounter an isosceles trapezoid. What's an isosceles trapezoid? The two legs are congruent. It also has a relationship with the diagonal. What the diagonals relationship? They're what? They're congruent, okay? And I don't know if that will come into play, but that's just a good review there. Okay, all right, so let's do this first problem. It's pretty straightforward. I've given you all the information. Don't forget that you need to write your formula down for each problem. So it's half the height times the sum of the bases. I know that you don't like doing this, but it helps you keep all the information and make sure you plug it all in. As we get closer towards like volume and surface area, those formulas get a little trickier, and it's easy to get them confused and to leave parts out or add parts in that you don't need. So if you've got the formula written down, it'll help you keep from doing that. Okay, so my height is 30, and base 1 is 28, base 2 is 58. I'd probably take half of 30, which is 15, and then the sum of my bases is going to be 86. And so 15 times 86 is what? 1290, 1290, and we're in centimeters squared. All right, so any questions on how I set that up? Okay, now here's another example. The whole region here is shaded. One thing that I left out on yours are these little right angle symbols. Okay, so make sure you add those in. What shape is this going to be? It is a trapezoid. The fact that this 4 here is perpendicular to both of those makes these my bases. So this is my base 1, this is my base 2. And this is going to be my height. Okay, it's rotated, but everything is still there. Now, do I have enough information in order to solve this right now?
No.
What's missing?
The base 1.
The base 1. Okay, so I've got to figure out what this base 1 is going to be. So what I might do is I might draw the other height here, which is still 4, and I create a rectangle here and a triangle up here. What should I do to help me figure out what this base 1 is? Any ideas?
Well, do
Pythagorean theorem?
yeah, that's...
Use the Pythagorean theorem.
And then subtract 2 from divide.
Yeah, okay.
You get
So we're going to do the Pythagorean theorem to find this length here, subtract it from 10, and then it'll be our B1, okay? So I'm going to do 4 squared plus, we'll call this x squared, equals 8.5 squared. So I've got 16 plus x squared. What is 8.5 squared? 72.25. Okay, subtract 16 from both sides. What's that going to give me? 56.25. Take the square root, and x is going to be 7.5. So I find this right here to be 7.5, which means the other part is what? 2.5. Which means this right here, the B1, is also going to be 2.5. Okay, so now I can plug it into my trapezoid formula. Okay, so I've got half my height, which is 4, and base 1 is 2.5, and base 2 is 10. So half of 4 is 2, times 12.5 gives me an area of 25 inches squared. Everybody see what I did there?
Yes.
Okay. Any questions? All right, so that is my trapezoid. Now I'm going to work with the rhombus or the kite. And you, like I said before, you use the same formula for both figures. It's half diagonal 1 times diagonal 2. Now let's just go back over the properties of the rhombus and the kite. The rhombus is a quadrilateral. It's a parallelogram. Okay, all 4 sides are equal. What relationship do the diagonals have? Okay. They're not congruent. They do bisect each other. They are perpendicular. Okay, they are perpendicular. Okay. All right. Okay, and then we have our kite. Our kite is a quadrilateral, but it's not a parallelogram. Okay. What else? Backtrack for just a second. What else do the diagonals do on the rhombus? They bisect the angles. They bisect each other as well. Did we say that already? We bisect each other as well. So that's going to be important. Okay. All right. Now our kite is it is not a parallelogram. Okay. It is a quadrilateral. What relationship do the diagonals have? They are perpendicular. Do they bisect each other?
No. They bisect their angles.
This one does. The red one bisects it. This one does not, but you know, they're equal. These two angles are equal here. These two aren't necessarily. The blue diagonal is bisected though, isn't it? Okay. The blue diagonal is bisected. All right, so those are some of the properties. All right, now, this is a rhombus. All right, so we want to find the area of this rhombus. So it's half diagonal 1 times diagonal 2. Now, it tells us that this part of the diagonal is 10, and so is the other part. So this whole diagonal is going to be 20. Likewise, both of these are going to be 12, so this diagonal is 24. So we plug it into our formula, and what's diagonal 1? 20 times 24. Okay. You could do it like that, 240, and then take half, okay? And that would be, no, it would be 240. Yeah. There we go. This is what I would do. I would take half of 20, which is 10 times 24, which is going to be 240. I think Missy skipped a step for me. I think you did it all in one step. If we had multiplied these two together, it would have been 480, and then we would have had to have taken half of that, okay, which would have been 240. So you can do it either way. Remember, you can take half of one or half the other or half their product, okay? Never half of both factors. All right, here's another one. Again, we're working with half diagonal 1 times diagonal 2. My diagonal 1 is what? Okay, you want to do 15. Diagonal 2 is 6. I'm going to take half of 6, which is 3 times 15, which would be 45. So 45 meters squared is my area there. Or I could have multiplied 15 times 6, which is 90, and taken half of that. All right, any questions? Pretty easy, yes? All right. And then we have our graphing problems that everybody loves. What should be the first thing you do? Graph. Please sketch a graph of kind of what it's going to look like, okay? Sometimes that's helpful to you. I went ahead and graphed this one on mine already, okay? We want to find the area, and this happens to be a trapezoid, and our bases are horizontal, our height is vertical, so all is good, right? That means we don't have to use the distance formula, okay? All right, so remember our formula is half the height times the sum of the bases. All right, so let's go ahead and count. What's the length of EF? 6. And the length of HG? 11. How about my height here? 5. Okay, good. All right, so my height is 5, and my bases are 6 and 11. So we end up with half of 5 times 17. I don't want to take half of any of that, do I? So I'm just going to multiply 5 and 17 together and take half, and I get 42.5. And since I don't have a unit of measure, it's going to be units squared. questions on that one? All right, 2 more. Up, like that. Oh, down. I guess you're right. It's up to you, but it's down to me because I have to pull it down. Yes. My finger. I have to pull it down for it to go up. I have to pull this down for that to go up. No, I don't. Never mind. Forget it.
We want it to go.
Okay. Never mind.
It looks like it's going up, but it's going down.
Yeah, that's why I was confused. Okay. All right. Here's another one. It says rhombus WXYZ has an area of 92 square meters. Find XZ if WY is 22. Okay, and I'm looking for XZ. I'm going to let it be X. Now we're working with the rhombus, so my formula is half diagonal 1 times diagonal 2. What's diagonal? Well, my area. Yeah, the area is 92. Diagonal 1 will let be 22, and diagonal 2 is X. So I'm going to go ahead and take half of 22. Half of 22 is 11, so I get 92 equals 11X. And then I can just divide both sides by 11, and I get 8.4 meters, because it is a diagonal. All right, last one. Trapezoid PQRS has an area of 250 inches squared. Find X. So we're working with the trapezoid. Again, my formula is half the height times the sum of the bases. Okay? It tells me that my area is 250 inches squared. Okay? So I'm going to plug that in for the area. What's my height?
10.
Missy's ahead of the game. She's already taken half of it. And then X is one of my bases, and my other base is 30. Okay? So I probably would go ahead and take half of 10, which is 5 times X plus 30. Then what would I do? Distribute the 5. So I end up with 250 equals 5X plus 150. Subtract the 150 from both sides. And then divide both sides by 5, and X is 20 inches. All right, any questions on that? So we had 2 formulas, okay? We had our trapezoid formula. The area is half the height times the sum of the bases, and then our rhombus and kite formula, which is half diagonal 1 times diagonal 2. All right, one more thing I want to just point out to you, and this doesn't have anything to do with the lesson. However, I did see it quite a bit on the test, okay? On our last test, a lot of our answers were ordered pairs, okay? And I had a lot of people leave their answer like that. What's wrong with that? There's no parentheses, okay? And with the Common Core that's coming up, they're going to take off. You might have a problem worth 4 points, and you might do all the work right, but then give your answer without the parentheses around it. They're probably going to take a point off, because it could be a vector, couldn't it? It could have this notation, which means something totally different, okay? This is a translation vector. This is a point, all right? So it's important that you don't be lazy and make sure that you denote your answer correctly and don't leave those parentheses or whatever brackets happen to be supposed to be there off, okay? All right, your assignment is on the board.